Hello students, welcome you all. In my today's lecture, I will explain the preparation methods of alkyl halides. So alkyl halides that can be prepared by different methods. For example, we may prepare from like alkenes, we may prepare from alkene. Even one alkyl halide can be prepared from the alkyl halide by substitution reaction. Even from alkyl halide, one type of alkyl halide may be prepared from the other alkyl halide, or Hunsdieker reaction, where we use the mercury or silver salt of acid is used, and another method that we may use is by alcohols. We may prepare it from alcohols also. So these are the different ways by which we may prepare the alkyl halides. So first of all, I will discuss the preparation from alcohols. So see, from alcohol, now, so suppose if we have ethyl alcohol or any alkyl alcohol, if we have, then the replacement of alcohol OH group by this halogen, that is not easy, because this OH group is a poor leaving group. So that's why to replace the OH by any halogen atom, so we should convert this OH into a good leaving group. Then OH can be substituted by any other halogen atom. So in case of when we prepare the alkyl halide from alcohol, then one of the main condition is that the OH group that should be converted into the good leaving group. So OH group for we can say for the preparation we can write the OH group being poor leaving group, okay, so should be converted into good leaving group. In presence of some acid. Okay, for example, we may take the halogen halides. We may take the different halogen halides can be taken for it. Okay, so this OH group that would be in presence of halogen halides, the OH group that would be converted into this H2O, and this H2O, we know that H2O is a good leaving group. So we may take different halogen halides, and the reactivity of this halogen halide, we know that this reactivity of halogen halide, then it is Hi being highly reactive, then this HBr, then HCl, and then this HF. Okay, so out of these different halogen halides, this Hi, no doubt Hi can be used, but here this one of the problem with this Hi is that it gives the reversible reaction. So here the reaction is reversible. So to make the reaction reversible, we may add some oxidizing agent here. So we will see it. Now the reaction with HF, this is explosive one. So overall, this is the best acid that we may use, that is the HBr, or if we see for this HCl, HCl is a weak one. In comparatively, this HCl is weak. That's why when we use HCl, then we may use some catalyst also to increase the rate of reaction. The catalyst may be used. So this is the reactivity order for the halogen halide. Okay, and then reactivity order for this alcohols. If we see the reactivity order for alcohol, then tertiary alcohol being more reactive than the secondary alcohol being the primary alcohol. Okay. Why? Because here, if we are using tertiary alcohol, then we get the tertiary carbocation, and that would be the most favorable one, and the rate of reaction for that would be high. So when we have tertiary alcohol, okay, when we have tertiary alcohol, then the reaction will go via SN1 reaction with the formation of carbocation. So for tertiary alcohol we may write reaction follows SN1 path. SN1 path with the formation of carbocation. Okay, where the inversion as well as the retention product that would be formed, and the retention product that the inversion product predominates over the retention product. And for primary alcohol, the reaction follows SN2 pathway. Okay, where the inversion product that is formed. Now, for secondary alcohols, we see for secondary alcohol the reaction may takes place either by SN1 or SN2 path. So reaction follows SN1 or SN2 pathway. Okay. Now, so what I have told that reaction with HI, this is reversible one, reaction with HB are quite good, and HCl, this is slow, where HF is explosive. So now if we want to use HCl, then reaction is slow. So to make the reaction fast, we may use some catalyst. So reaction in presence of HCl is carried out. If we are using HCl, then here it is carried out in presence of some catalyst, that is ZnCl2 catalyst. So reaction with HCl is carried out in presence of ZnCl2 catalyst. And this is also called as a Lucas reagent. It is also called Lucas reagent. So in presence of ZnCl2 catalyst, it makes the reaction for primary alcohol, and it can react easily in presence of ZnCl2. But this now this tertiary alcohol, no doubt, because the reactivity order for this tertiary alcohol is very high. So the reaction with HCl may take place, and when we are using the tertiary alcohol in presence of HCl, that may take place in absence of ZnCl2 catalyst, because this tertiary alcohol being the highly reactive one, so it may also take place in absence of ZnCl2 catalyst. But if we are using primary alcohol, no doubt, so this Lucas reagent or ZnCl2 catalyst, it will make the reaction fast, as well as the secondary alcohol. Okay, so this is about some of the points when we are using alcohol for the preparation of alkyl halide. Now, some of the examples. Now if we are using suppose primary alcohol, and this primary alcohol in presence of HBr. So what I told you, this hydrogen bromide, this is quite reactive one. So in presence of this hydrogen bromide, so this is primary alcohol. So what type of reaction? So first of all, this OH being this poor leaving group, so we have to make a good leaving group, and we are making a good leaving group by adding one of this acid. So that would be converted into H2, and now in next reaction, next step, this bromide ion that will attack from the back side, and here the reaction will follow the SN1 and SN2 pathway. Okay, the backside attack will takes place in case of this primary alcohol. Okay, and we will get the bromide, alkyl bromide will be get. Okay, so this is for primary alcohol. Now when we are using the, suppose if we are using tertiary alcohol, if you are using tertiary alcohol, then in that case again so this will follow the SN1 pathway, means formation of a carbocation will first take place, and then we will get the alkyl halide. Okay, so now suppose if we have the reactant, suppose this is the reactant, what would be the product? First of all, this oxygen that would be protonated, and the next step, this H2O molecule being good leaving group, it will leave out, and what we will get? We will get a secondary carbocation over here. We will get a secondary carbocation. Now, what is possible here? Whether this bromide, whether the nucleophile will attack over this one, or so no. So otherwise, what is the possibility that two hydrogen atoms are present over here? So it will the proton transfer, this shift of hydrogen shift, hydride shift that will take place here. This hydride shift will occur, and we will get a benzyl carbocation. So benzyl carbocation being a stable carbocation, resonance stabilized. So this is the driving force for this hydride shift. So we will get a benzyl carbocation, and now this nucleophile that will attack over here, and the product that we are getting is this would be the product. Okay, so this would be the product in this case. Now suppose our reactant is, now if this is our reactant, then in presence of HBr, what will be the product? Now again, this will be oxygen that would be protonated, and the water molecule, it will leave out. The water molecule, this will leave out. Positive charge over here. Now in next step, the hydride shift that will take place over here. So the driving force for this hydride shift, the formation of allyl carbocation, that is the driving force for this, because allyl carbocation being resonance stabilized, so this is the driving force for this one. And now the nucleophile that will attack, and we will get this product. Okay. Now some more examples. Suppose if we have secondary carbocation, okay, and this is our reactant molecule in presence of HBr. So in presence of HBr, first it would be protonated. It will leave out, and here we will get a secondary carbocation. Now, what may happen in the next step? The bromide, the nucleophile will not attack over here. Why? Because the secondary carbocation here, that may be converted into the this tertiary carbocation by the hydride shift. One of this hydrogen is present over here, so there is a chance of hydride shift. So that's why by hydride shift we are getting this tertiary carbocation. Secondary carbocation is converted into the tertiary carbocation. Now the bromide ion will, as a nucleophile, that will attack over here, and we will get this one product. So here hydride shift has taken place. Now suppose if we have one of the methyl group is present over here also. Now this is also a secondary alcohol. This is secondary alcohol. This is also secondary alcohol. But here what you have seen, hydride shift has taken place. Now suppose in place of hydrogen we have the methyl, then methyl shift that will occur. So in either here, no doubt the methyl shift will not occur. The hydrogen shift will take place first, because hydrogen being the smaller one, so that can easily shift in comparison to this methyl one. Okay, so here what you will get the product. First of all, same one, in presence of this acid, it will get protonated, and will leave out secondary carbocation, methyl shift, tertiary carbocation, nucleophile attack, and you have alkyl halide like this. So this will be the product in this case. Okay, now suppose if we have four-membered ring, the OH group that is present in a four-membered ring, then the four-membered ring, which is the strained ring, that may undergo the ring expansion, and that can be converted into the five-membered ring. So if you see the example, then in this example you will see the ring expansion. Okay, So here if you see in presence of HBr, so that should be present over here. Which okay. So removal of this water molecule and positive charge is generated over here. Now in next step, what is possible, this 4-membered ring being this strained ring, here this ring expansion will take place with the opening of this 4-membered ring. Now suppose I number it, this is 1, this is 2, 3, 4, and suppose this is 5 and 6. So ring that will be opened and this 1,4 bond that will break and it will open like this. So what we will get? We will get like this, and the positive charge that will come over this first position. So this is here first one, this would be second, third, fourth, and this would be fifth, and this is the sixth carbon. Now, so this could be written as, this could be written, so if it is first, second, third, fourth, and this is fifth, and that fifth one of the this methyl group is present over fifth position, and here the positive charge is present. Now in next step, this nucleophile will attack over this positive charge, and we will get this 5-membered thing. So this would be the product which occurs with the expansion of ring. Now, so this is about the preparation of alkyl halide from alcohols. Now, suppose in place of HBr, alcohol may also react with KBr and H2SO4 to give alkyl halide. Now, actually, in this reaction, if you will see, actually this alcohol is reacting with hydrogen bromide only, because this KBr, reaction of KBr with H2SO4, they are giving hydrogen bromide plus potassium hydrogen sulfate. Okay. In the same way, this alcohol may also react with, in presence of potassium iodide and phosphoric acid. It also gives the alkyl halide. It gives alkyl iodide plus this would be the reaction. So here also this potassium iodide and phosphoric acid, they are giving hydrogen iodide plus this K2HPO4. Okay, so we are getting here hydrogen iodide, or we are getting this hydrogen bromide. They finally react with the alcohol. Now, reaction of alcohol with hydrogen chloride, I told this is quite slow reaction. That's why we need a catalyst. ZnCl2 catalyst is used. So if we are using HCl, then reaction is slow. and that's where we should add ZnCl2 catalyst. Okay, so in presence of this ZnCl2 catalyst, we will get the alkyl chloride plus this one. Now, if you see the mechanism for this, then alcohol in presence of ZnCl2 catalyst. So first of all, this lone pair of electrons present over here, loosely held electrons, this will go into the vacant d orbital of this zinc, and what you will get? You will get negative charge, positive charge will come over the oxygen and negative charge will come over the zinc and Cl2. Okay, now in next step, so we have this HCl in the reaction mixture. So chloride ion as a nucleophile, the backside attack, and so this bond will break. What we are getting? We are getting the alkyl chloride plus this positive charge over the oxygen that will get neutralized, and this minus charge over zinc is still, it has a minus charge in presence of this H plus of this HCl. So okay, and in the next step we have H2 plus ZnCl2. So this is the reaction. Now we may also prepare the alkyl halide when alcohol reacts with thionyl chloride. So reaction of alcohol, so this is one of the reaction, this is another reaction, this is next one, and the reaction of alcohol with thionyl chloride already I have discussed in my previous lecture. So this reaction that may take place either in presence of pyridine or in absence of pyridine. So via either it may take place with SN I reaction or otherwise it may occur in by SN1 reaction also. So this also gives the this alkyl halide plus okay, and so this we will get as okay. So this reaction, and we may get and this alkyl halide in presence of PCl5 also. So this is some of the reaction of alcohols. Now see, we may also see the reaction of this alkane and alkene when suppose if we have a alkene. So suppose if we have simple ethylene and this in presence of suppose HBr, so what it will give? So this HBr molecule, it will attach over this double bond. So we will get the alkyl halide. So this is the symmetrical alkene. Now if we have unsymmetrical alkene, suppose if we have this propene, then this unsymmetrical alkene in presence of this HBr, so this follows the anti-Markovnikov rule. This is either anti-Markovnikov rule in presence of peroxide, or it may follow the path that is Markovnikov rule, and where it will occur in absence of this peroxide. So suppose Markovnikov, this is addition is suppose addition is Markovnikov addition, then what will we get? This nucleophile, that is bromide ion. Bromide ion will attack over the carbon where there is a less number of hydrogen atom. So otherwise, if we want to understand this mechanism, then why this carbon at this secondary, we are getting the secondary alkyl bromide, because we will get the secondary carbocation. So and secondary carbocation being more stable than primary carbocation, that's why we are getting the secondary alkyl halide. Now, so this is in absence of peroxide. This is in absence of peroxide. In presence of peroxide, so that is called as the anti-Markovnikov. So we are getting the primary alkyl halide in presence of peroxide. Okay. Now from alkane also we may prepare. From alkane, suppose if we have methane. So methane in presence of this chlorine, what it will give? So chlorination of this, that will occur, and this chlorination, it takes place via the free radical mechanism. Okay. Now, so if we have, suppose propane. Suppose if we have propane, then the product form, that would be either secondary alkyl halide, or we may also get the primary alkyl halide. We may get the primary alkyl halide, but secondary alkyl halide, it would be the major product and this will be the minor product. So this takes place via the free radical mechanism. Now next, that is the one of the, that is from alkyl halide also we may prepare the another alkyl halide. So suppose if we have and here this X, it may be either so this in presence of alkyl iodide. So iodide ion being a better nucleophile, so that can replace this bromide ion and chloride ion. This reaction. So it occurs in presence of some solvent, for example, it may be suppose acetone, like this. Now one of the last reaction, that is Hunsdieker reaction. Next, by this Hunsdieker reaction, so if we have this silver salt of this acid in presence of bromine, that gives the alkyl bromide. So this reaction, it takes place by the free radical mechanism. So if we have silver salt of acid plus this bromine, so this will give plus this AgBr. In next step, OBr bond being the peak bond, it will break and it gives the radical Now this further the CO2 molecule that will release, and we have the alkyl radical. Okay, now this alkyl radical, again it will combine with one of this molecule, and so this bromide radical and this alkyl radical, this it will give the alkyl bromide, and plus we have another alkyl radical again. So this radical will again combine with next molecule of this, and in this way this is a chain type of reaction. So these are some of the methods for the preparation of alkyl halide. Thank you.